And on the bench today we have a Konami Amidar PCB. And this one is a little bit poorly because it's not starting up. It's just giving me garbage on the screen. So we're going to have a little investigation. I've got the board extended out so I can lay it out flat because the piece of ribbon cable that they give you to interconnect the two is like that, but it doesn't need to be stacked up on top of each other. So what we're going to do is see if we can trace down where this little fault is on this board. So I'm going to hook up the logic probe for a start off and see where we go from there. Here is the Z80 CPU, and what I want to do is have a look at the clock signal and the reset signal on here and see what's going on. That's the first port to call. So I've identified the CPU, and this is Z80. So first thing to do is check the clock signal on it. So I've got the logic probe here, and the clock signal is on pin 6 on the CPU. So pin 1, 2, 3, 4, 5, that's 6. Yep, pin 6. And the logic probe is pulsing. Now that's a good indication of the clock signal. Now I can't really tell what the actual speed of that is, but I'm going to take it that unless it's blinking rapidly or had some other indication, I'm going to kind of assume that signal pulse is okay. I could get the oscilloscope out and do the math and figure out exactly if it's the correct signal for the board and all the rest of it. But for the purpose of this, let's assume that seeing a pulsing signal is a good thing. Okay, let's proceed on to the reset line. The reset line on the Z80 is on pin 26. So it's a 40 pin chip. So that's going to be pin 1, 20, 21, 22, 23, 24, 25, 26. Aha! 26 is stuck low. So I'd expect to see one of three things here. Either I'd expect to see a high, which means the CPU has come out to reset. I'd expect to see it blinking backwards and forwards between high and low, which means it's what they call watchdogging, which is another process which we'll not get into here, but basically means that for some reason it can't execute program and it's going to keep trying to reset the CPU to try and get it to come out of, to solve that problem. And it's not doing that, but we're stuck low. Now, what I'm going to assume here is we're stuck low, so the CPU is in reset when it is low, because this is active low reset line on a Z80. That would say to me that the problem is not actually after the CPU, it's before the CPU in the reset circuit. So next up to do is consult the schematic. Here's the Amidar schematic, and this is the lower board with the Z80. What we've got here is your reset line at pin 26. Now that says reset with an overline on the top of it, meaning active low. Okay, so I've had a quick look through the schematics, and this isn't a real-time thing, I've actually been and looked at this bit. Here's the reset circuit. Zoom that up. And here's where it leaves the reset. And there's a positive reset there that goes somewhere else. I haven't really looked at where that goes to. That's possibly one of the sound chips. But the reset basically comes working its way back here. And it's effectively its input into the reset, or its output to the reset circuit, is at pin 10 of 4D. So we know we know absolutely for certainty that we have a low signal coming at that pin. So what we need to do is look at where we're coming from, where we're getting signals from on this. So this is 4D. So pin 8 of 4D is fed by pin 6 of 5C. So let's have a look and see if that chip's faulty first. So that's basically the thing to do with these is to try and work backwards. It's all about spotting what you think is wrong. So what I'm going to do now is find location 4D on the board down here, and I'm going to find pin 8 of that and see what's going on there. And I'm going to work my way back through that and then see if I can find a problem. So this is pin 8 of 4D, which is an LS02. And I've put the logic probe onto here, and what I'm finding is every now and again I'm seeing it flick. And if you notice up here, the game has part way come out of reset. It's trying to reset, in fact it's there. It's managed to come out of reset. Okay, that's interesting. Now if I take my, so that would tell me that I've either got There you go, and it's reset again as the thing. So I think I'm going in the right direction here. So according to the schematic, pin 8 of 4D is fed by pin 6 of 5C. Now pin 5C, so that's 1, 2, 3, 4, 5, C. 5C there is an LS00. Okay. Now this is basically a quad NAND gate. So I'm expecting to see inverted inputs. If I work my way back in from there, obviously pin 6 of 5C feeds pin 8 of 4D. So staying on that 4 and 5, so basically whatever's going on pins 4 and 5 of 5C is going to be governing. Let's see, so to get it to reset, let's see if I've got this the right way around. To get it to come out of reset, I need a 1 signal to appear, and a high to appear at pin 4. So let's have a look there. Now I should have 5C, so we can get the pin on pin 4 and actually get it the right way around so I can see it. Yep, that's correct. So I've now got a high signal on pin 4 there, and the game is out of reset. So I'm heading in the right direction here, so let's see if we can figure out anything else that's going on before it. So that there, so these resistor, I can check the resistance there, work my way back. So there's 2 transistors here, and a capacitor here, and a capacitor here, and a diode, sorry, here and here, and a diode up here to look at. So it would look like the two ICs here are fine, potentially some dry joints underneath, we can reflow that, and we might have a problem either in one of these 2 transistors. Now I've actually been making some posts on UKVaC about this whilst I've been trying to diagnose it, and we actually think, and I'll put a link to the thread about it, because this video is kind of being shot in staccato form, where some things are happening, then some things are happening in non-real time. So we seem to think that it might be somewhere around here. What I've done is I've replaced the 2 capacitors because they looked bad anyway, and they're 30-year-old. So I've replaced those 2, and it made no difference to it. Now, interesting that pushing on pin 8, pin 8 of 4D over here seemed to bring the game out of reset. So I'm going to turn the board off. We're off. I'm going to turn it back on, and let's see. So it's come up now as that, and it's come out of reset. Okay, so that's interesting that would happen. Okay, why has it decided to come out of reset? So this whole thing stinks actually of some problems underneath the board, on the pins to these ICs or to various passive components in the circuit. I think a little reflow work's required here, so let's do some of that. Let's reflow around pin the 5C. Now we've got to come out to reset 5C, which is that one, and the 4D over here. So let's do those first and see where we get to. That's those 2 ICs reflowed, and I've switched back on, and the game came straight up. So I'm struggling to find a component that's actually at fault here. I had suspected along and had been given information, in fact been given some great help on UKVaC, that the problem was likely to be with this PNP transistor here, because we weren't, when I had done some logic probe, some circuit testing going backwards, off air as it were, and found that basically this is a PNP, so this junction needs to be off in order for the rest of this circuit to work. And we were finding that the base was greater than the emitter, so therefore, but we were still finding voltage coming through here, down in the collector. And that led us to believe that that was actually the problem. So, you know, gone ahead and ordered some new parts and waited for them to turn up. But one thing we did try on the forum was I was told there's a 1k resistor. Basically, was lift that, which would create a nothing here, which would then which would be the same result as that being switched off, and it did actually work. Did that? So what I was trying to show you was working backwards from the reset line here, all the way up through the reset circuit, and find the fault. It seems actually I found a different fault whilst trying to explain the problem that we're actually, and actually teach people through the problem we're actually having. So I'm struggling to find an actual faulty component. Like I say, I replaced the two capacitors here and here, so maybe it was just down to connectivity. Now this particular board, I have had problems with it continuously resetting. Now I originally thought that it was problems around the CPU, so I reflowed all the pins underneath the CPU and around this header connector here, because these are notorious problem points, and that seemed to get rid of it. Now we've just managed to reset the board there, so I think we've still got a problem, and that was when I was kind of leaning over and I might have just shorted something out. You don't know, not really quite sure. Anything could have happened, you know, it's quite possible I caught something. I'm tempted to replace the two. I've replaced the two capacitors anyway. I'm tempted to replace the two transistors, just purely out of curiosity more than anything, and see if I can get the problem to go away once and for all. I've reflowed around the two main ICs that are in this circuit, certainly up here, because I wasn't getting the correct output here, so obviously work your way backwards through the circuit, work your way back to here. I wasn't getting the correct low high signals here, so I'm tempted to just replace these two transistors anyway whilst I've got the board on the bench, because it probably will solve, it may just well resolve all the problems anyway. However, during testing, if you read the notes from the UKVaC post, you'll find that definitely I could not get the board to come out to reset, and as you saw, it definitely was stuck in a reset beforehand, but we seem to have kind of fixed it via another means, so we're not quite sure what the possible problems are. So I'm going to go and get the capacitors that I've the transistors that have arrived. I'm going to pop a new one in here, and another one which belongs to the same circuit in here. Now these are two SA ones, 2SA and 2SC, PNP and NPN transistors. They're equivalent to BC327337. So I'm going to go and get the two relevant transistors, and I think I'm going to pop them in there, which will mean I've reflowed around there and around all these resistor packs and everything, and that hopefully should keep the game nicely back working like that. So the 337s and the 327s are a slightly different pin configuration. So when I was checking online, obviously that wasn't really that much of a factor. I didn't really consider that. Anyway, so what I've done is I've fitted these in just with a slight change around of how they're actually set up on the board. So I'm going to solder them in, nothing's touching. So we'll get in and in. To all three of those. Right. That's the replacement for that one done. Okay, so what I've done is I've had to twist it around slightly to fit, but nothing's touching, and I will get the correct component afterwards. Something similar. Yep, no problems there. that's that one. The same with this one. What we really need is a BC639 and a BC638 complementing pair. So here comes the bag in little bags of 20 at a time. These will get used somewhere. Double check this one. Using my set of wearable jeweler's loop, which I'll just use to have a quick look at the code. Yep, that's a 327. Another configuration is CBE. It's not the correct configuration for the PCB. As I say, I'll get the correct component. 639s and 638s. I've got some I think I might have some 639s. I'll do both at once. There we go. We are in. Just give them a twist like so. Once the legs are in, and make sure they're not touching, which they're not. So we're kind of putting it into a slight angle. I'm super conscious for the possibility of shorting, but I'm making sure that doesn't happen. Flip the board over. There are my 3 leads. Get the iron and some solder. Right. Find some snippers. Brand new pair of snips. You don't want to clip them too close. Oh, there's the ones for this side. Take both of those at once. That's it, we're done for that. Okay, I'm going to just double check them again, make sure I'm not going to short between base collector emitter. No, so as long as nobody pushes on those 2 transistors, which nobody should do anyway, I should be able to clip that back onto there. One last thing I wanted to show you all was when I was talking about reset circuits and the fact that the state should change on the logic probe when the board's actually working. So now we've fixed the board, or well, we've found something wrong and we've done some remedial work and the board seems to be working now. So what I want to do is to show you what should actually happen as it comes out of reset. It'll only take a second to do. So reset on the Z80 CPU is pin 26. 1, 2, 3, 4, 5, 6. There's pin 26. Now what should happen is I'm going to reach over here with this hand and I'm going to switch the test rig on. What you should see is it go low and then high. Try that one more time. Yep, flicks low, then flicks high. And just in case you couldn't see it with the light on, we'll do it without the light on. you go. Did you see it flick low to high? And that's a good clean reset. Right, let's switch it on and test it out. Hey, there we go. Nice clean reset each time. And we have the game playing. Well, I'm going to call that a result.